Hello and welcome to Iron Biddle, a show where you can hear me but cannot see me. Okay, let me try to fix this. Okay, so hopefully it is better now. Let me check if okay, this one also doesn't work. Bear with me. Okay, no, doesn't work. Sorry about that. Okay. Yeah. We're back. Welcome to Iron Middle, a show where we normally just, talk about TigerBiddle, and well, also, to be fair, look at the code of TigerBiddle, this cool distributed database for financial transactions implemented in Zeek. But today we have something special. Today we actually go to do some live coding for a change. Okay, let's get started. What are we going to hack on today? We are going to hack on the simulator. If I find my browser. Okay, no browser. Okay. Okay, this is here. Okay, so as a reminder, we are looking at how our deterministic performance simulator works. And the simulator is called VOPR, and the idea is that we are running a bunch of replicas on a single computer, and moreover, on a single process and on a single thread. And the reason why we are able to do this is that because we are able to, because we do distinction between physical and logical. We think about what is it in our database that is physical, like, network messaging, disk I/O, time. We think about what is logical, messages, blocks, ticks. And then we carefully slice our code base so that we could model it, we could simulate it at the logical layer. So that's kind of like the idea of a simulator is that we have a simulator, and this simulator maintains a bunch of state machine. And then there is a heap of events you could use to feed those state machines. So at any step of a simulator, you pick a random event out of heap of events and feed it to the state machine. The events are ordered by time, so you pick the event which is ready to get going. And let's see. Okay, let's move it out of the way, and let's call it. How would we call this branch? Tickless VOPR. No. Tickless VOPR strikes back, because it is like going to be like the third take on this idea of Tickless VOPR. Okay, so let me try to show you the problem. Let's look at our test and storage, and let's see how we implement the API in our like logical test storage version. Okay, I think the font size is a little bit too small. Okay, yeah, because this is work, not play. Well, 26 is a bit too high for me. Let's stick with 22. Okay, so this is our test and storage, and here you see that the way we implement a write is that we add it to this priority queue of events, and then we go and sometime later fetch all the writes which are ready at a given moment in time. And herein lies the problem. So the way we model time right now is in terms of ticks. So tick is 10 milliseconds. And when we have a write, we say at what tick it is ready. And when we initialize VOPR, we also specify like the write latency in ticks. So everything happens at the tick granularity. This is problematic for two reasons. Reason number one is that it is just unrealistic. Disk writes are going to be significantly faster than 10 milliseconds. We should model this faithfully. The second reason is that this leads to many different writes being ready at the same tick. And if you are in a situation where several writes are ready, what you want to do is that you want to pick a random write. And that just requires some like tricky code. So you see like we have like this like ready queue type whose only purpose is to do this like removal of random ready read. So this is the design bug. The design bug is right here. We model latency in ticks. We really should be modeling latency in nanoseconds in real time. Okay, so let's do this, I guess. Um, okay, first of all, we have standard X duration type, which encapsulates time in nanoseconds specifically. And it makes sense for us to use duration here. Okay, where we were. Okay, so let's say that all those latencies are actually durations. Then in the VOPR, when we initialize this, okay, so it should be constants. Okay, so what would I, so ideally I want to say something like milliseconds. Okay, so this is, okay, this is kind of like a thing where Zeke has maybe a little bit too little in terms of the types, because I kind of like don't really want duration to be like a dedicated type. And I just want to have like units of measure. I just want to say just okay, like duration is just in nanoseconds. Okay, but let's see. Maybe it is not that bad. So time ns pure ms. Okay. Okay, actually, okay. I mean, we can add some helper functions here. Range inclusive ms. Mean u64. Duration, and we want to export duration. Okay, and we need PRNG here. So we want u64. Okay. Does that sound reasonable? I mean, this makes MS. Okay, it doesn't fit on my screen, so let's format it that way. No, I don't like this. Okay, so then this is range inclusive mass PRNG. Okay. Okay. Okay, so here we do wait. This feels incorrect to me. This feels like it should be buggy. No? Oh, okay. So here I want to say that mean value is something between minimum and okay, so inclusive mass. How can I write this simply like that? Eh, okay. Let's do this. Let's do this in like stupid way. Um, then okay, yeah. Then this API will work. Uh, just don't have to spell time here, but well, we can. And the same thing for max. Hey, now this fits in one line. Okay. This is good. Okay. Not the best zip code I written, but it's fine. Okay, so write latency. So read latency was 10 and write latency was 100. So we want actually 1000 up to a second. Okay, so I think this works. Okay, let's see. Let's just see. Let's just see how much stuff breaks. Zigbee VOPR build. Hey, actually, it seems like only storage breaks, which is good. Okay. So directly compare nanoseconds here. Allocate is a word. Read latency, so those also want to be durations. Well, we do have durations here, then why? Okay. No. Okay, and we want to return a nanosecond. Which is going to be, well, which is going to be this thing over here. Uh, I don't love how this line is so crowded, but I also don't have a good name for this thing. If you have a good name for this thing, please suggest in chat. So I'll let it be. Okay, so now oh, I definitely don't like how these two are not symmetric, so let's make them symmetric. And okay, you see, just we place them on two lines, and immediately you see like how everything's aligned. Read latency mean, read latency mean. Actually, okay. So time. Now, actually, I don't need. Can we use priority queue here? Okay, so let's see. Let's see. Let's also say now. By the way, this. Oh no, this cannot be. Can this be? Okay. So this wants to be an instant. So I want to return storage fixed times constant stick mass std time mass pure ms. Okay. So now add now plus instant. Well, let's also call it now. Duration instant. Does it look reasonable? Yeah, it seems it does. And by the way, I mean, I stole this design with duration in the instant from Capital, and it does help to not confuse the types here. Although I wouldn't call this now because we kind of like going to tick instant. Okay, let's do this this way. Then ready add is going to be just instant. And then okay. We'll get in there. Okay. No, I don't think I actually need already. Okay. I don't think I actually need ready queue here. I think I only need priority queue. And when we create priority queue, do we... Okay, yeah, so... storage read less than. Storage write less than. Okay. So what do we do here? Okay, as John Carmack told us, whenever you refactor, you don't just modify the code in place. You always copy it, and then you work on a copy to be able to quickly contrast and compare. Okay, so I think I want storage reads peak e read e read. It shouldn't be ready at tick. It should be ready at and should be just instant. And I guess we don't even need to name the context here because it is pretty obvious from the context what this context thing is. Done it. Oh wow! You see? I think that was that code, which flew by our dead code detector because it is very simple. And so basically, we have a dead code detector, which is super stupid. It warns simply about unique non-public declarations in a file. And well, because we had two less than functions, they are not unique. Okay. So what do we do here? A storage disk instant. So if this thing happens, then what we should do is that we should say storage. Well, basically we should say this thing. Does it sound reasonable? Okay, so if read and it is. Is there some kind of like pick if functionality? Not really. Okay, I think it's fine. And the same thing goes for writes. So let's quickly. Okay, ready, tick. Tick instant nanoseconds. GT is totally a word, dear spell checker. Context full. Okay, no, I definitely don't want to fix typos in the external library. Expected type. Okay, yeah, because this one actually wants to be void. Okay. Ready queue type. Priority queue void storage. We less than. It would be so much nicer with Zig 0.14, but we didn't quite yet migrate it here. Sounds about right. Note. How do we need priority queue? Wait. How come we... Okay, how is it called ready queue? Okay, yeah, we need ensure total capacity. So this actually is without try. Instance oops, max. Okay, this sounds right. And really, this edit is a little bit repetitive, so probably I should be using some kind of, you know, large language model here. Yeah, but well, someday I'll grow into a professional programmer to use all the tools. Okay. This is the priority view. And this is not. Okay. A bunch of errors. What do we do here? So I think this wants to be a while storage rights. Remove. Remove all null. I don't think we need reset. I think we, oh, okay. Do we have something like reset clear, remove all? I'm telling you fold all, okay. Then remove count capacity, shift down, append slice. Okay, no. Shrink and 3. Well, we don't want to shrink. We actually want to keep everything. Okay, so let's see. One is storage reads. Remove on now. Just going to drop it on the floor. Okay, and I don't fully agree with Team 10 opinion that like you should never write continue, but I think that on the margin it is probably best avoided. Okay. What is this? Okay, already add. So I want to say tick instant add storage latency. Actually, I mean this reads quite nice. Tick instant add read latency. This exactly add is there like capacity add unchecked. Why is this okay? Yeah. Well, one of the problems with Zig is that the standard library isn't really do we have some kind of storage slice items? I think we can do this. Okay, yeah, because I remember there was a bug once. I remember once priority queue used items to denote both allocated and unallocated items. So like, you know, like the entire capacity, not only the size, unlike array list. but that is fixed in version of Zeek we are using, so that's fine. Already at catch and reachable. Okay, range inclusive. Okay, we definitely want PRNG here, and we want PRNG here. Very, like you see, like many people, when they read Tiger style, the section about assertions, get completely wrong idea out of it. That if you use assertions, you shouldn't be using types. This is not at all what Tiger style says. Tiger style says that you should apply layers to your code base, that it is never ever possible to produce code which is entirely bug free. There is no silver bullets. Every technique will catch some bugs, but will miss other bugs. So what you do want to do for reliable software is to layer as many defensive layers as possible. You want defense in depth. You want this kind of like medieval style armor there, where there is like, a very thick coat, and then there is mail, and then there is like a plate on top, and then you still get killed by a bullet. So we do use types here. We don't use like raw 64 here. We use like type duration, because in this place, types help us. Okay, so this is neither U64 nor duration. Then what the hell is this? Let's see. What? Okay, I don't get it. It says like, hey. Int. Maybe. Okay, yeah. Haha. Wait, it compiles. Hey, we fixed bugs. Okay, that's great. Ready queue type. Okay, we are moving faster, faster than this. Okay, so let's see. One way. Okay, let's fix the network the same way. One way. Well, no. So we want to say that this is duration, and this is duration. And what is duration? well, this is duration. Probability, duration. Okay. Let's, again, this is probably okay, so we want we want to clock for nanoseconds. Good. Okay, so we want to clock for duration. No. Duration. Okay. Clocked till. Why do we do this? This is horrible. Okay, so we just save it. Hey, clocked till equal self tick instant add delay. Well, it's not ticks. We clock for duration. Oh, let's be stupid. Duration. This is why I don't always love introducing strong types, because actually, in like like duration doesn't tell you what it is, and like duration NSU64 actually contains more information because it tells you, hey, this is like U64. So that's why, for example, we don't do like checksum. But for duration, again, because it is easy to confuse duration with instant, and it is easy to confuse units of measure, using a dedicated type is helpful. Clocked for duration. And actually, do we have a format? No, we don't have format. Well, let's add format. How do you write format in Zig? I never remember the signature here. Okay, so duration. I want to say std format duration duration ns format options writer right. Okay, where we were. Okay, yeah. Tick instant add duration packet delay. Okay, let's see if and tick instant self packet simulator. We are going to return an instant, and let's quickly add so I want self ticks constants. We don't have constants here. we have constants everywhere, so I don't actually remember how are we supposed to import it. Okay. Somewhere we don't super constants ticks ms ms ms, and we want to return the same. Okay. Package delay, then it goes to be duration. This also goes to be duration. And this goes to be ns. Okay. Okay, now we need to change the type of vtable, because packet delay now returns a duration. And yeah, you see, kind of like, yeah, you do want to use types, but instant. Did I make a typo here? Typo there? Should I have used instant somewhere? I think this is fine. Or tick instant. Okay, actually, no. This is a typo here. Thanks, Nosiam, if I'm pronouncing your nickname correctly. Thanks for spotting this one. Okay, this should be better. I'm missing dot. Great. Why there is no tick instant? I've just edited. No. Oh, okay. So there's actually a second typo here. Okay, clocked till. Let's actually call it moment rather than time. Till. Okay, so I want to say that this is ready at tick instant, add package delay, and we remember that wait, did I type catch? Huh. You see it? Yes. This is oh dear. This is a bad bug. This should have been catch and reachable. Okay. Don't have this anywhere else, which is good, but still. Okay, so what is a queue? Queue is now a priority queue without context and with link packet less than. So context is void. We have link packet, link packet bool, and we say a ready, and it's not tick. This is instant. Why do you not love this? In the storage. Okay. Packet. There's still don't. Okay, yeah, because those aren't actually pointers anymore. So this wants to be std priority queue link packet void link packet less than initialized with allocator. Actually, let's do this, and then we say that link queue, sure, total capacity, and what did we have here before? Thanks, VS Code. Options path maximum capacity. Path maximum capacity. Oh, you need the context, and the context is void. Then we don't have an allocator here, and probably there is one more in dnit. So here we just say items. Yeah, here we don't need allocator. So what do we do here? While queue pick if already at an s greater than key storage. Let's see. No, not this storage, this storage. Let's see if I haven't messed this one up. Okay, so the instant we are going to break. Okay. Take instant nanoseconds. Oh, this one. Okay. I mean, I think we could queue There is okay, I've lost okay. Index, and for index we'll say PRG index Q items. Remove index returns an item. So that's all correct now. Okay, so range inclusive MS PRG, and then we multiply multiply everything by 10. So 5 ticks duration. MS pure MS. Wait. So 5. This one is kind of like stupid because, well, probability is 0 anyway, but well, we'll let it be. Okay, refactor is done. I will want to take one more look at it afterwards. Well, actually, no. Wait a second, because we didn't do what we actually wanted to do, and that is kill and ready Q type. Well, now refactoring is complete. Okay, so I'm not. No, I'm going to open a draft request because I do want to take a closer look at the diff outside of the stream to make sure that I haven't messed up anything. And in particular, I'm not sure if I shouldn't be adding ticks plus one when computing tick instant. But I think you've got the idea about the change. So basically, we were scheduling our IO based on ticks. And now we are scheduling it based on like real, but still virtualized time. We've done a second precision. VOPR take 3 real time. Okay, so let's wait until we push this. And draft pull request is ready. So we deleted about 40 lines of code, which is slightly less than one line of code deleted per minute, which is actually pretty nice because I mean, there is like, if we compute work week as 40 hours, then multiply that by 60 minutes is like 400 by 6 is like 2,400 lines of code. So you see, if we continue at this pace, we could remove 2,500 lines of code per week, which means that like in, I don't know, maybe a year, we'll get to zero code entirely. Well, sadly, it's not always that easy. Okay, folks, hopefully this was a nice distraction from our usual talk mode, where we went and improved our simulator, where we figured out how we could better schedule I/O in such a way that it is, if many things happen at the same time, which one is ready is more random. Please, if you haven't got everything, you could always watch the recording on YouTube. And if you'd rather watch live rather than on YouTube, then please join us next week on Thursday at 5 p.m. UTC. Have a nice day outside. Goodbye.